Alright, another draft physics video presentation. This was sort of something I had myself wanted to get to, but a commenter has provoked it, so this video should be differently titled, indicating it's for a purpose, which is to list experiments that could be done to shore up our understanding of what the reality is. Obviously, experiments are everything to physics, in my opinion. Unlike Bill Gates, you need information to combine to see the truth, so to speak. You need dots. If you're going to connect the dots, you need dots, and experiments are the dots. Now, I've sort of argued that all the experiments of physics aren't very well detailed and aren't done in any kind of meticulous way and aren't done poking the experiment, seeing what you can make happen. The video camera, cheap video cameras, that is, well, within the reasonable realm of common man purchase, have been around since the 70s. And you can't find the videos anywhere of experiments actually being done in some sort of careful and well monitored way, and that's really bad on physics, right? Lots of people doing physics, lots of laboratories, lots of universities, and as I've sort of pointed out, at the universities, they're all show experiments. They just do it one way to show one thing. They quote mine the experiments to prove their point, and it's clearly done. And some experiments you can't find at all, like Stern-Gerlach. There just isn't any data of anyone ever doing the experiment, in the sense of no video, no pictures, no anything. Barely. I mean, yes, you can get a picture of the results in some photographs, but very little about how the experiment is conducted. And it's supposed to be fundamental to this whole idea of electrons having spin and all of this property they invented for electrons. And it is an invented property, but anyway. So yeah, there's these questions have been around a long time. What if you do the two slit in a vacuum? I mean, it should have been done. Frankly, you can put the whole experiment in a bell jar. You just need a better screen. You got to use a decent detecting screen to see the pattern, but it's all doable. Not that sophisticated or complicated. A few $100s, and why isn't it? Why don't we have that data? So anyway, this all goes to like LIGO. There should be lots of experiments where LIGO demonstrates, how their mirror is so sensitive. They swing a weight over the tunnel. They do something to demonstrate how they can measure, 1/10,000th of the thickness of a proton, kind of stuff. They should be able to show us how brilliantly sensitive the machine is. With tests, there should be tests done, and they're not done. All right. So anyway, I'll get to it. So the only comments here that are relevant are comments talking about experiments, citing experiments, showing experiments, explaining experiments you'd like to see, that kind of thing. The rest of it is just not on the subject, and won't be appreciated, and likely won't remain as a comment. So anyway. So yeah, I won't get to mine yet. I'll read the comment. Can you please break down what experiments you would like to see done? I'd like to see the ones that have already been done, but I'd like to see them done better. So there are examples like the Eddington experiment, which never been repeated, with commensurate technology, in over 120 years. I mean, why? Space technology never used, when it's a huge advantage over doing the experiment from the ground. I mean, it's such a gigantic advantage. You don't need an eclipse. It's a huge advantage. No one has ever thought that we need to do this, or did they think we needed to do it and they figured out it doesn't work? I mean, what's the truth here? I'm supposed to believe that no NASA scientist, no scientist who has any capacity to direct technology in any direction ever thought to say, why don't we do the Eddington experiment? None of them? Ever? Anyway, I mean, it would be a guarantee that you'd get your money back, so to speak, in just the cachet of being able to say you verified something, fundamental to relativity and Einstein physics. Never done. I mean, those are just open questions that there's no reasonable explanation for why. There's only unreasonable ones where you have to figure that, gee, I mean, all the physicists are this stupid. They're so full of woo and so chasing their unicorns. They're so busy doing that. They don't understand they need to shore up their basic conclusions with something called evidence. Anyway. So, and then there's other arguments like the mathematical problems with gravitational lensing, and the fact that I haven't heard any rational explanations for how the wrong shaped lens creates images, magnifies distant objects, and the other problems where it's not a material lens, so it can't do the time adjustments that regular mechanical lenses do. They slow photons down. Well, a gravity lens can't do that. And things like Einstein rings have no theoretical possibility. I mean, even if you overcome all of the defects in the wrong shaped lens and all the rest of that stuff, an Einstein ring should, by theory, be too small to see. And yet they claim they have a picture of it. I mean, the theory says you can't see it. Why are we seeing it then? Anyway. So lots of this stuff just has to do with experiments that have already been done, but done so poorly that what we're going to rely on Faraday's notes. I mean, you can't actually redo a Faraday experiment. Come on. This is this is bullshit, frankly. All right. Anyway, moving on. I've heard you mention charged surface double slit. That's just one of them. So there's all kinds of things you can do, right? You can make the slits hot. You can make the slits cold. You can charge the slits. You can use magnets. You could use, I probably said in a vacuum. So yeah, I could just list some of those. The one I've most recently pointed out is that they should, well, I'll draw that one, so we'll wait. Damn this, I gotta get a new cord. Stop it. Anyway, stop it. I command you. As Lord of the local universe, stop. Anyway, I've heard you mention charged surface double slit and repeating some astrological observations. Well, whatever. If that's what you want to call them. I would call them astrological observations. I'm sure there's more, yes. Anyway, I think it would be interesting to spend some time describing and drawing out some experiments. You could mention exactly why it is important and how it has been done incorrectly. Thanks for your time. I really appreciate your content. Okay, well, the first one that comes to mind, again, this one really stuck out at me, is when Professor Lewin did the radar experiment, the MIT, and it's just a repeat of an experiment they recorded in the 60s or whatever. And so they project that this is some verification of their wave interference theory as they take two radar sources. Our antenna sources, it really doesn't matter. You can do it with regular lower frequency, regular broadcast radio. You just have to do it outside. You have to have much larger distances to do the experiment. So the advantage of doing it with 10 gigahertz is that you don't need centimeters. It's a centimeter wavelength, so you can see within a couple of meters of desk space. You can do the experiment. So the idea is you have two radar sources instead of slits, and they're fed by the same frequency, the same impulse frequency, so they're in phase. And the idea projected or stated is that there's two of these waves created, the waves overlap and the waves are interfering with each other, and you get the traditional on-off pattern on the screen. Now, this is how they explain it. Okay, so yes, there's physicists who have other theories about some sort of random entanglement thingy going on here, or some other kind of nonsense about how waves propagate, but obviously the most sold of the physical interpretations, a new piece of chalk needs help, sold by the interpretations is that there are these physical waves, and, and the physical waves are interfering with each other. You know, they're colliding with each other, and at all these little X points or something's weird. They're becoming wave packets or some other kind of nonsense, and that's why you have a pattern. All right, now my argument is the simple way of gleaning some more evidence. So this is what I call the quote mining. So they do the experiment a certain way, and they come up with a result, and they say, it must be wave interference. Now you just do a few changes to the experiment, and you can pretty much dissect that that's not a good explanation. It's not the right answer. So my change to the experiment is just position the two guns this way, facing each other, so they're fed by the same source. And you put the detector in between, and then you just move one of these. And the truth will be, is you'll be able to get an on, you know, and then an off, and then an on, and then an off, and then an on. And neither of these waves can get to each other, quite obviously, before they get to the antenna. There won't be any possibility of being at all confused about what's happening in the experiment. None of these are writing very well. Okay, anyway. Yeah, and so it kind of it's counter evidence against their theory of this entanglement, or this idea that the photons are interfering with each other. But what you'll find out is that no, in this case anyway, it's just jamming. You're just signal jamming. So when you have these waves out of phase, that is, one wave is hitting the object while the other wave isn't, you'll be able to see that that the fact that there's no harmony between the two waves means that you'll confuse your receiver, and it won't be able to discern signal, and you'll get on and off. And you'll get on and off because there'll be a place where the two waves are in sync, and then there'll be places where they're out of sync. And when they're out of sync, there won't be any signal. The other thing they do is they put an audio signal on this traditionally. So instead of measuring the actual energy, they're amplifying a signal. And that's where it really breaks down, is because the amplification process, they're amplifying the amplitude of a signal, and when you amplify its amplitude, you quadruple its when you double its amplitude, you quadruple the strength of the wave. So the area of this is like the inverse square law, is doubled when you double the height. And so they end up with a signal that's actually 4 times on and then off, and then 4 times on and then off, and then 4 times on and then off, or 2 times on, however you want to look at it. They end up with twice the signal when it's on, and the twice is just because they're converting an audio signal that's just in peaks into a sine wave. And when you do that, obviously you change something that didn't have a volume into something that does have a volume. That is, it has a duration where it didn't have one when it was the original signal. Well, anyway, so they use all of these little tricks to imply this has to be wave interference, when clearly it isn't. And so I say that rather simple experiment, I mean, if you have the equipment, it's not a complex, very expensive experiment to do, but it will demonstrate how these waves never interact with each other, and you create the same exact signal. All right, on to the double slit versions. All right, so right, so so yeah, so I don't think there's any variation on the single slit that I could think of, but obviously it's both hold for double slit or single slit. So the idea would be to try it with these things being magnets. Okay, I haven't seen it done with two magnets. You know, obviously they'd have to be a little thickness to the magnets. You know, and that's another part that they don't do is why don't they do the thicker and thicker experiment? You know, make the slits thicker and thicker and see exactly how much energy you lose, how much it changes your pattern, you know, depending on how thick the surfaces actually are. Because clearly that's going to have something to do with it. That'll tell you something about whether, you know, the energy is actually bouncing around between the slits and ends up getting absorbed, and so you end up with less light. So the longer the slits, the longer the surface is, the less light you get in the output. Also indicating this isn't about waves, this is about surfaces. But yeah, so make them magnets, charge them, you know, put a charge on the surfaces, a plus and minus charge, or two negative charges. Do the experiment in a vacuum, and then you know, hot and cold, you know, heat them and cool the surfaces and see how much that changes what comes out in the pattern. And you know, these are all really simple, you know, technically. I mean, there are kind of things that should be done in a lab and blah 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 and all that stuff, but I mean, these are all doable experiments. And you can't see any evidence that they've ever been done. So let me just check my list and see if there's anything else. Alright, charge plates. Oh yeah, photographic film. So the one you haven't seen either is put photographic film. You know, film is pretty high resolution. Put it really close to the surface of the slit and see if you get any change in the pattern. Because technically it should make the pattern pretty soon and quick, and it should be there. I was also thinking the CCD chip could also be put really close to this area and give you a great deal of, you know, the chips are very small, so you could put it right in front of the slit, the light's going through this way, and get a pattern. Obviously you don't have to use a high intensity laser, you just need a few photons, but that's part of the argument. Is, you know, part of the argument being made here is that when you see a photon, it means there's more than one photon that's actually heading for a location, and that the photon you're getting back is just the fact that you've used pieces from different photons to make a photon. There's no such thing as a gun that shoots a single photon. That anytime you see a photon bouncing off a surface, it's more than likely that more than one ray of energy actually hit the surface, and it required more than one ray to actually create a composite that created the photon that left. Yeah. So what else? Check the list. Oh yeah, the other one too was the photo, based on the you know, the photographic film idea. You know, you got your light coming in this way. Put the photographic film here and here, and because technically, you know, their theory is that there are the same pattern is going to all locations, so technically you should be able to get the pattern on these surfaces as well. It'll just take longer. So do that experiment, because that would tell you something too. It would tell you there's a question that's open. It's even open to me. You know, about how the light actually does scatter. I would argue that it's probably scattering a specific angle for each interaction with an electron, but even if we made that variable, so it could be almost any direction, there's a real question about how many bars of light can actually be created, right? I mean, you see the pattern, and some patterns you see have 15 bars in the middle, or 17 or 16 or 18. There's always this, you know, in the two slit pattern, because it has these, you know, it's really two patterns, it's not just one pattern, there's pattern inside the pattern, but these clumps are always of a limited number of bars, inside these clumps, a specific 8, 9, 10, 11, 12. What's controlling that? And I would argue what's controlling that is the thickness of this material, because it's giving you more opportunity to hit more electrons. So the thicker the material, the more likely you are to have more bars, because you're able to hit more electrons in your path, and it's electrons that are creating this pattern. But their theory essentially says this should be infinite. You know, this pattern should get duller and duller. I mean, it's obviously going to be brighter here, and less bright, and less bright, and less bright. But the point is, there are actual photons going to all these other locations by their theory, and you should be able to detect them. And if you don't detect them, if you didn't get anything here, that would tell you that there are a limited number. And why would there be a limited number would be the question. Their theory doesn't say there should be a limited number of a limited amount of scatter. It says the scatter should be essentially probabilistically real in all of these locations, that there's a real probabilities, not fake probabilities, and that they would be detectable. So it's a question that needs answering. In my opinion, would be very informative, but it wouldn't verify their theory, and that's why the experiment isn't done, is because all it can do is prove their theory flawed. It can't prove it right. The answer is not going to be the answer is not going to make their theory right, and it has every possibility of making their theory impossible, and that's why it's not done. Okay. All right, the other one was this, another argument can be made within the realm of real technology, is they keep talking about how if you know which slit it goes through, this can't happen, and the whole experiment falls apart, and blah, 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 blah. So they make it seem like it's some sort of real, meaningful thing, that somehow you have these two slits. And if you know which slit the photon went through, that somehow it defeats the whole, having that knowledge will mean you'll have no pattern. And so I would argue that clearly they do have lasers now. They're quite capable of being aimed, they're small enough to get through this 1 millimeter or less, half millimeter even, and they could aim the photons. So yes, you can't detect a photon when it goes through the slit. You can't sit there and create a detector that tells, oh yeah, the photon went through here, the whole, because photons are terminated by you seeing them. If you detect a photon, you've stopped a photon. There's no way around it. The only way to see them is to stop one. They don't believe that, but I'm just saying that's what the evidence really indicates. And all their fake experiments is where they think they rubbed up against a photon. You can't rub up against a photon. Can't happen. You can't have an electron sit somewhere and have the photon just drift by and the electron say, oh, I felt the photon. The photon kept going and minded its own business, but I felt it, and I jiggled. That doesn't happen. But anyway, I don't think they have any evidence for that notion. Where was it? Yeah, so I think I could do this experiment, so I think I'll try it someday. But anyway, you take 2 lasers, and you shoot one laser through this slit, and one laser through this slit, okay, and you see what kind of pattern you get. And I don't think there'll be any doubt about what you're going to get. But anyway, the idea would be either one. Either you just move the laser so it goes through one slit or the other slit, and you always know which slit it went through. The trick is that I'm arguing that this phenomenon does require a certain amount of light. You can't deny that there has to be, at the same time, there has to be light being scattered off all of these surfaces at the same time. There has to be photons going into the system in both slits at the same time. So you really have to use 2 lasers. See, if you switch the laser back and forth, well, then you're only activating one slit at a time. And yeah, you won't get the same pattern because you won't be able to make the mixture between this one and, say, this one, or this one and this one. So the idea is simply that when you're putting the photons through here, my argument is you're breaking the photons. Some of the photons are being broken by the surface absorbing part of their energy, and then as the photons go through, some bits of the photon are being deflected in different directions, and really all you're doing is recombining them where the wavelength path differences are whole wavelengths. So where these distances, two lines can create the extra length of this path versus the off phaseness of this path remakes the photon out of two different photons that are out of phase. So you're really just remaking new photons out of photons that are out of phase with each other that were out of phase. So it's just this bit argument. Okay, the photons are coming through like this, overlapping each other. They're not on a straight line parallel. They have a polarization, and that really the photon you see has a bit from this one and a bit from this one and a bit from this one, and you're just lining up the bits to create a new photon. So you really do have to have energy in both slits at the same time to see this pattern, and I think that's the simple truth. That you're not seeing the photons you put in, you're seeing broken photons go through the experiment, and then you're recombining them at these locations. So there is no destructive interference, there's just constructive reconstruction of photons you broke into pieces. Alright, let's see if there's any other. So yeah, I mean, it's just kind of a simple experiment, right? The fact that there's just, I haven't found any on YouTube where somebody shoots two lasers, one through each slit. I mean, it's just not that difficult. Alright. What else do we need? Pinpoint laser, yep. Separate lasers. Oh, okay, so the detecting thing is the one most recently I pointed out. Okay, so instead of looking for light, I would argue that there is no destruction of the energy going through. So you are just putting pieces, and there's still pieces hitting the whole thing. So the whole thing is being hit by the same amount of energy everywhere. There's no difference in the amount of bits hitting. There's just some places where the bits recombine to make a visible photon, okay, and some places where just broken bits hit and you don't see anything. So the idea would be is you take a very black surface that, as black as you can get, so it reflects very little, so you're not fooled by places where it's more reflective because you made more photons, and you just detect temperature instead. So instead of looking for light, you just look for temperature, because a broken photon is really heat, and you'll be able to measure it. So just a bunch of little thermocouples put on the target, and I would argue that the results will be that you will find that it is consistent amount of energy across, and that there is no difference in the amount of energy going to the locations. There's just a difference in whether you reconstruct something you can receive. And just like the radar experiment, you get the same results. There's the same number of microwave bits of energy hitting across the whole surface, and the reason why you have places where you detect and where you don't detect is merely you've reconstructed the proper frequency. So there's stuff hitting at all the locations. It's just that at some locations you can reconstruct the signal that you can receive, and in some places you don't. So I think that would verify that this has nothing to do with the real amount of energy, that all it's doing is scattering it essentially off the surfaces. The surfaces have electrons on them. The fact is the photons are broken by the electrons, and you're just reconstructing them at the target, and that explanation works. And if they do enough poking at this experiment, you'll find that that is the correct answer, that it will be demonstrated by doing this experiment with a little bit of poking, with a little bit of playing around with it. And by playing around with it, you will detect the truth. And instead of quote mining the experiment, forcing it to do one thing and one thing only, that verifies the theory. So I guess that's enough on that. let's understand we still don't have any rational explanation in the single slit for their theory, because water waves do this. Okay, water waves do not create diffraction. They create a nice, clean, single wave that goes through, and that's all they do. Yeah, it should be back. Better check. Yeah, looks like it. Alright, anyway, so they've never come up with any kind of rational explanation for why in light, unlike other media, somehow two waves are created here. Like somehow magically in the middle here the photon gives up and it just splits into two magical, photons for which there's no explanation, and creates the pattern. So a complete disconnect to their theory. Doesn't verify their theory, is actually evidence against their theory, but they'll never talk about it, never explain it, blah blah blah. Likewise, the double slit experiment does create the two patterns. They have no theoretical explanation for why that second pattern's there. They can contrive mathematics to explain it, in the sense of they can create mathematics that just basically makes rules. Well, there's a rule that it has two patterns, but it's all just made up. There's no reasoning explaining why there's two patterns. There's no explanation for why the wave interference thing creates two patterns. No way to draw it as a rational explanation. Anyway, all right. So then there's lots of stuff about the interferometer and beam splitters. So I don't know how much of it to go into, because I don't know how much of that I remember. But clearly, one of the key things is how much, I would argue, is how much energy you put in. So the idea is you reflect light off a beam splitter. Light can take either one of the paths. You put mirrors and output. So you're bouncing the light back here and bouncing the light back here, and ending up with two beams here that they are arguing or interfering with each other in this location somewhere, which again I say is nonsense. So a key thing is that you're put in a lot of light. So a lot of light goes in, very little light comes out. And they've never really quantified that. Where do all these photons go? Where are they all destroyed? In LIGO, they're bouncing this light 1,600 times back and forth between this mirror. 1,600 times. 1,600 times going back and forth, 2 miles, 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 2 miles. So yes, they're putting in, gigawatts of energy with their laser. They're getting, milliwatts of signal out. Where's the diagram of where all this energy is going? There's no explanation. Just raw theory tells you that you're going to go in, each time you reflect off a mirror, you're going to go in a different amount of depth into the atoms. So if the atoms are, like this, one reflection you might hit the first atom, on the third reflection you might hit the fifth atom. Every reflection is going to hit a different atom. So where your mirror actually is changing just because you're hitting different atoms in the mirror. And when you're doing it 1,600 times, that's an awful lot of irregularity in the distance to account for. And this is huge irregularity in the sense that these atoms are a huge amount of distance apart from each other compared to the width of a proton. So they're saying they can measure a tiny difference when, how can they do that when they can't even hit the same atom each time? An atom in the same position. I mean, the theory doesn't make much sense. There's no explanation for it, why it quote-unquote works. How these could ever be equal beams when part of the light's reflecting off this surface, part of the light's reflecting off this back surface, and then some of the light reflects off the actual mirroring. The mirroring is obviously not 50-50. To create a 50-50 beam splitter, the mirroring has to be a lot less than 50%. we're back to the single slit argument. It's diffracting the light in one beam, the other beam isn't getting diffracted. So none of these things have been dealt with as questions regarding how the experiment functions and what changes you could make to it to create the results. It really doesn't have anything to do with what can be learned from what these patterns really are, and these patterns really are what thin film creates, and that is if you put two things next to each other, and if you have an angle in it, the fact is the light will bounce between the two surfaces and create pattern. And the more the slope, you can sort of understand that the narrower that slope, the more reflections that can take place in a certain amount of space. So in an amount of space, you can have more reflections. The tinier that slope line is, the more and more you'll get. So the closer they are to level, the more little lines you get. The further they are from parallel, the bigger the lines will get in terms of your pattern. These are, there's just a whole bunch of these facts that aren't really dealt with as understanding what's going on here, which connects to what's going on here. These two subjects can't be dealt with as different subjects because they're creating the same theoretical pattern, and the cause is really the same cause, and they don't really want to deal with the fact that there's a limited number of internal reflections that take place in that beam splitter, and that's really what's controlling it. The other beam splitter, besides the half silver mirror, the other beam splitter they use is exactly this: a prism with a small thin film placed in between the two sides of the prism. So they're actually using this theory in the beam splitter. So I mean, this isn't dealt with, that there's a mechanical limit to how many of these things are going to be created. There's the reasoning of why they're created, and none of that's dealt with in their presentation of their logic behind the experiment. So again, I would argue that the interferometer is again dependent on taking a bunch of photons that are concise and in right form, and you're really just sending different pieces of the different photons in different directions and putting them through a process, and what you're really trying to do is just see how many pieces you can put back together again that restore the frequency. So you just take a bunch of these little ball bearings, you shoot them off in different directions, and some of them you'll be able to put them back in a reasonable order. So that is, within a certain polarization, you'll put them back in the correct sequence to create a photon. So you're just remaking photons. These experiments are all for one purpose: to break photons. You're sending photons through some sort of mechanism that will break them into pieces, and you're scattering the pieces, and then you're just trying to see how many of the pieces you put back together again. And that's all that's really taking place. There is no interference, there is no destructive anything in the sense of interference. There's just destruction of the photons in breaking, not destruction, just reorganizing. And then you just put back, so it's just constructive reconstruction. All you're looking for is where you reconstructed the proper frequency, and that's it. Alright, it's accelerator experiments. These get kind of complicated. So, I mean, somebody wants to ask a more specific question about exactly how photons are accelerated, which is a sort of an important feature of this whole thing. But the idea is they take a plate or a piece of metal, they heat it, they cause bits to fly off of it. They say they're electrons, let's say, for example. They put them across a charge, which causes them to move, accelerate or move, and then they put holes in the charge for the electrons to fly through, let's say. And so they're creating a beam of electrons, is the point, by giving them a plus to minus thing to jump across. Now the question is why can't they shoot the electrons at varying speeds? I mean, why can't they make electrons that travel 25 miles an hour? Okay, because the truth is, in accelerators, they're either going like almost the speed of light, you know, 7/8 the speed of light, and they can make them go like 6/8 maybe is like the slowest they can ever. So it's just making them go a little faster, a little tiny bit faster, a little bit faster. And what they're measuring as energy, when they say these are high energy electrons, they start just measuring how much heat hits the target. So instead of measuring speed, you know, how fast did it take for the source, these things to get there, instead of measuring its velocity, they start measuring the density of energy hitting the target, which may not be electrons. So I would argue that what's really happening in these experiments is there's rays of high energy photons that are being created with the pulses. And those rays are very long rays, as long as the pulse, and that the point is the electron is being pushed by that ray, and it takes, and then when the electron's going 7/8 the speed of light, it takes quite a while for the ray to use up all its energy pushing the electron, because the electron's going pretty fast. So it's as if I shot 10 bullets and you were moving just a little bit slower than the bullets are moving. So, you know, you would understand that the bullets will come into you kind of slowly and give you a little bit of extra momentum, but, you know, just keep you moving. And so it may not be that these accelerators are actually accelerating the products that they think they're accelerating. That what they're actually measuring is how much gamma radiation their source is producing. And sort of the evidence for it is that when they make these accelerators, especially linear accelerators, they put a big, giant, fat wall here before the target. Okay, because if anybody's standing here, he's going to get irradiated. So it's sort of an indication that you've got more than just electrons moving through this pipe, that you're actually shooting a whole bunch of high energy photons, you know, and that's what you're going to expose somebody to. That's where the radiation is coming from. So there's a whole bunch of, when they have this stream of what they're saying is a stream of electrons, it's really they're shooting a hell of a lot of energy, and that's why they have to put shielding here to protect people from getting killed, is because it's a lot of radiation. Electrons aren't going to kill this guy. A bunch of high energy photons will kill him, you know, and that's what's coming out of the experiment. And again, so they're just measuring the, you know, so as the heat goes up, they say the intensity of the electrons went up. When no, what went up is how much energy you're throwing at it in terms of how many gamma rays and X-rays you're creating, and the X-rays are what's actually hitting the target now, and you're just measuring an increase in the X-rays. You're not measuring an increase in the energy of the electrons. So, so what can be modified to detect all of this stuff is that, you know, accelerators are pretty complicated, so it's a little hard to make this argument. But I guess I would argue that, you know, some of the accelerators that rely on the magnetic field and are doing this you know, swirling thing, they spin it inside these two you know, containers, and create this charge differential, and you know, to get it to spin around and around and around. That what they're really spinning are dipole atoms. You know, they're not electrons or protons. And what they're really doing is when they actually scrape it off to go somewhere, that's when they scrape the electrons off the atoms. The electrons aren't really spinning around in here. But anyway, that's, you know, these are all arguments that really require whole videos to even explain how the experiment is supposed to function, let alone how I would redo it. But these are, like, you know, these are obviously not experiments a person can do. All right. So another one that's sort of interesting is all the vacuum tube kind of experiments, cathode, anode. You know, you have a tube of glass, you're shooting electrons through, and you get very different results. You know, when you put a magnet, you know, you could put a magnetic field north, south, and you'll have that. One theory says, well, yeah, the north end repels electrons, so the beam goes this way, and it'll go to the south end. And then the other one is that it's going to do the inverted thing, where you have the two poles, and instead of you shoot the electrons through, and they go up instead of like a wire pulls up instead of or down, however you switch the polarity. So there's two theories. I mean, does the North Pole repel electrons, or does it cause electrons to go up and down? And the question is, the problem is that they fool you by having different things in here. So like the radiometer, the traditional little radiometer with the little spinning triangles. The catch is, if they have a full vacuum, this thing doesn't work. They actually have to have less than a complete vacuum. They have to have a gas in here, or it doesn't work. And the key thing is here is the same thing. To do these electron experiments, to see the electrons, they pump a gas in. They put atoms in here, and then we end up seeing the atoms creating light when they're ionized. So the question is, are we seeing the electrons, or are we actually just seeing what the atoms are doing that are being ionized? It's a real question. Are we seeing electrons doing something, or are we seeing atoms that are doing something, and then they're on fire? The atoms give off a little photon. So we're just watching what the atoms are doing, and we're not watching what the electrons are doing. So these are real open questions, because in a complete vacuum, then you can't see anything, and so then they use a phosphorescent paper or film. And the problem with that is that, yes, now the gamma, the photon energy, can excite the film. So you don't know whether you're seeing, am I seeing where the actual beam of electrons is, or am I just seeing where high energy photons are hitting the fluorescent paper? So all of those experiments need a lot more whatever the word is, playing with. You got to tease them a little to get a little more information about exactly what's happening. Let's see. So the last thing I talked about was, let's see. Something I did want to point out in another video, so I might as well point it out here since I'm doing all this other stuff. There was some comment on one of the John Chappell people, and I made some sort of comment. I'm not sure about that experiment. So apparently they attempt to detect, like, when the moon is going over the sun, and they're expecting some sort of gravitational change here on Earth, and so they're measuring light versus the speed of light versus the speed of gravity, and they say they get some kind of different number. I don't even know if that's a valid experiment in the sense of what their expectations are gravitationally, but let's say that this would be more gravity than when the two objects are separate. So the more separate they are, the more condensed they are, that we should get a change in gravity. But obviously it's going to be a very slow and gradual change. So it's kind of hard to say that they could match that up well enough. But the real point I wanted to make was that accelerometers require something to be moved, physically. They're measuring acceleration by measuring the actual movement of something. So the argument would be the simple argument that accelerometers are a very slow detector. They don't detect change very instantaneously. Just like it takes time to accelerate the space shuttle. We can have a big giant rocket engine, and the rocket engine is firing, and it's firing, and it's firing, and the shuttle's still sitting there. Okay, it takes it a while to get the shuttle to start moving. And so we can detect photons rather quickly. There's a photon hits, the energy moves very quickly through the system, and the light bulb goes on saying photon. Where with the acceleration, it's kind of slow. It takes it quite a while to get the shuttle moving and blah 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 blah. So it doesn't say acceleration at nearly the same speed. It's much slower detector. Okay, so I just want to point that out. And so the next argument is All right, so yeah, so last one, I think we'll call it a day. Well, I could probably read the rest of those jerky comments, so maybe I'll do that. I don't know if it's worth a whole video, to just nag people. All right, so the one I'm curious of is magnets. Okay, so you take two magnets, something like this configuration, I suppose, something thin. Neodymiums would probably be really good for this purpose. This would be the north side, this would be the south side, and just charge them. Put them on strings so they're just at the point where they're not magnetic enough to stick to each other. So just have them in space, tied to poles, and they're just close enough, movable little stands. So they're just close enough where they can keep enough tension so they stay in these positions. And then put like a negative charge on both of them, of whatever, 100,000 volts, or whatever, 50,000, 40,000, I don't even care. And just see how much this charge put on the magnets, all right, this repelling charge, see which force is stronger. Is the magnetic function stronger than the electrical function? And my argument would be is that what charge does to a magnet is break it. Okay, the magnet's a filter, essentially, and it's taking what comes in, and stuff comes in and it's sending one part here, the electron sensitive, and the proton sensitive comes out the other end. So it's filtering. There's mixed force coming in and it filters. And the point is, when you charge it, you break the filter. You essentially clog the outside of that filter with a bunch of electrons. So now it's no longer working as a magnet, because everything that was trying to go this way ends up reflecting back this way and ends up leaving this way or this way. So it essentially just breaks the magnet by changing the surface by putting electrons on it or taking electrons off of it. You make the surface no longer magnetic, and so the magnet actually breaks because the surface isn't working anymore as the regular surface. You create a new surface, and that's all charge is. Charge is just changing the surface of something. It doesn't change the substance of the thing. It just changes how many electrons are on the surface. And so charge essentially disengages the function of magnets. So I guess I would predict that once you put charge on here, the charge will make the two magnets no longer stick to each other or attract. But it's a simple enough experiment. I haven't seen it anywhere, so if somebody can find such an experiment, I'd appreciate it. And such. So I guess that's good enough for starters. If I think of some other experiments that I can put it into some sort of text, I'll also include it in the comments. So variations on experiments that sort of need to be done. There's probably a lot about refraction, through substances. Just curious how much a beam, these are sort of technical things. How much does a laser beam spread when it goes through a thickness of glass? How much does it increase how much diversion there is in the beam? Because there appears to be some of that going on, and that might have something to do with this thing called refraction. But anyway, so we'll do some more of these comments and get out of town. Alright, it's tempting for some folks to consider time as the fourth dimension. I don't think it's tempting at all until somebody brings it up. Just like I don't think God is a great theory and everybody just gravitates to it because it's such a cool theory. I think it's just brainwashing. I think it's just that if that's all people are told, and if they keep being beaten over the head with it as the only possible answer, and they're never given any other alternative theories, yes. So I think it's just the droning effect. You can just badger people into thinking it matters when it doesn't. Truthfully, I've made the same mistake. General relativity tells us, it doesn't tell us anything. It might tell you something. It tells me people are silly. It always sounded silly. It will always be silly. It's just a silly answer. It doesn't tell you anything about how gravity functions. It's just a waste of time talking about bending two-dimensional space when we live in a three-dimensional universe. Anyway, Time is relative to the speed of the observer. Right, again, well, this whole observer crap is just so irrelevant. I mean, anybody who's going to do anything called physics, I don't think, why would you waste any time worrying about how things are observed when you know everything has to be observed slowly? You can't see anything as it happens. You can only see something, with huge lag in it, right? So I mean, observing something requires you to not, sometimes you actually have to use a flashlight. So first you have to send the light to the object, and then you have to wait for the reflection. So sometimes it's a pretty slow interaction. So you don't see the world as it is, you see the world as it was. It's just a fact. Everything I'm seeing as it was, not as it is this moment. And so what's so difficult about understanding that perception is meaningless here? We're talking about, when does things actually happen? Two bombs go off at exactly the same time. I don't change that reality by moving here or moving there or moving anywhere. Moving somewhere doesn't change the fact of it. Just nonsense. All right. We cannot see, and this whole idea, what they're trying to say is that somehow they know that as I speed up, that somehow my capacity to observe the reality slows down. So now I don't see most of the things happening. So everything looks like, everything. If I could see out the windows of the spaceship, I'd see the universe whoosh by, and I'd see everything's, all kinds of stuff is happening, and I'm like, whoa, in some kind of slow motion mode. And so all of this is sped up because I'm in slow motion, because I'm not seeing it. It's like I just went to sleep. If I spent if every second I went to sleep for a second, and then I woke up, and then I was asleep, and then I woke up. Yeah, okay, the world would be changing much faster, because, I'd be like, what the hell? Everything's moving too fast. But that has nothing to do with the reality. I mean, that's an anticipatable symptom of moving fast. There's nothing, you don't need any of this, oh no, but my capacity to perceive the universe is somehow relevant. It just really isn't. Even if it could change, it wouldn't matter. Still doesn't change the facts of the rest of the universe are really doing things. They're really, rabbits are chewing grass. Everything's happening, okay, at one speed in the universe. There's just no variable speed nonsense. Alright, we cannot say the same thing about physical distances, i.e. the distance between A and B as independent of the observer. Yeah, and again, observation can only be understood as a model. You model what you're going to see, but you have to understand that all observation is time delayed. So what's the point of even talking about it as being an accurate representation of reality? It's not accurate. Your observations are inherently inaccurate. It's just a fact. If I look at the moon, I am seeing the moon a second ago. Just a fact. And I'm certainly seeing photons that left the sun 8 minutes ago. I'm not, the light isn't something that got here, instantaneously or did any of that stuff. So, it's just stupid. But anyway, play along. So Clay and Putty videos, who just asking me to just get pissed off. I think, so I don't care again. I care about what you can prove, what you can demonstrate, what you can show to be true. Just this I think crap is just so fucking useless. And if you haven't gotten that yet, yes, go play somewhere else. Go play where everybody says I think and they don't prove anything. Because that's not what I'm interested in. Prove me wrong, prove them right. But don't waste my time with I think crap. Is bound to the third dimension. Well, what the fuck is the third dimension? There's no such thing as actual dimensions that actually are somewhere. Like there's no dimension this way and then dimension this way and dimension this way. This is again observer nonsense. There's no such thing as 3 dimensions. There just happens to be an orientation you can have in space that creates 3 or 6 sides, directions. 6 directions that are opposite each other. You could say 3 directions that are opposite each other. This is another, the right angle perpendicular thing is one way of saying it, but clearly it's just opposite directions, right? You got this opposites, you got these opposites, and then you have the opposite of in and out. But that's it, they're just opposites. There are not places. There is no first dimension, second dimension, third dimension. It's baby talk, mush, silly, not very well thought out. But again, what is this? I think. Who cares? You think why? Why do you think? Shit. Still hasn't gotten that. Anyway. And then, you know, these kind of comments are just inciting my contempt. Elon Musk is the most intelligent human on earth. I mean, this is just such an insane statement. He's a fucking crass little shenaniganser, right? He got started in business with his brother. His brother did most of the work. That's why Elon's share was much smaller. Then he took that money and invested it in a PayPal racket, right? One of these. I mean, it's hardly, you hardly need to be the most intelligent man on earth to say, hey, it'd be really cool if we had electronic banking. I mean, it's really not that complicated, right? That you could actually just transfer money electronically in the computer age, that we would get around to doing that. And what you really understand is that, shit, if I was going to write software to do that, why would I? It's so rudimentary, and that all you really need is you need some way to make it universal, so everybody has electronic money, and it's in some sort of safe and secure condition, and that's all this is about, right? And so this should be really some public domain thing. This just should be something we all don't have to pay rich people to have. We should all be able to have this as a basic function of our living here on Earth, debit card. And that's what all those systems are, right? You put the money in, you don't borrow money. Now, PayPal's trying to get people to borrow money all the time because they want to screw them over. So he invented a company that just screwed people over, just ripped everybody off. And that became PayPal. Big, huge ripoff. And PayPal was only successful because of eBay. So without eBay, PayPal would have just disappeared. It would have never been a thing. It was only a thing because of eBay. And so you say you have to be the most intelligent man on earth to do this horse shit. Then he steals Tesla's name when none of the technology in his stupid in the company has anything to do with Tesla's theories. So it should be called Einstein, or I mean, it should be called Edison, his car, because it's more of an Edison than it is a Tesla. And you think that's brilliant. And then this whole SpaceX horse shit that's just all showboating bullshit. Right? As soon as he puts men in these spaceships, they're going to figure out, you know what, I'd rather land with a parachute thing and all that kind of crap because it's real fail safe. You know, your whole let's make the rocket ship land back on its feet. Well, yeah, that's technically, lots of things can go wrong, and when they go wrong, it's complete catastrophe. There's no fail-safeness to it at all. It's just a stupid show. It's more expensive. It uses more fuel. It doesn't have any positive character to it all as a way of doing it the right way, the cheapest way, the most economical way. So again, not brilliant at all. Tunnels for cars, stupid as fuck. Vacuum tubes, none of this technology is original. Number one, he copied it all from like Buck Rogers, stuff that's been, you know, theories that have been around hundreds of years, and you call this the most intelligent human on earth. And you're supposed to think that I'm going to say, wow, what a credible source of information this bitch is. No, you're an idiot. You're a fucking idiot. I mean, he's a fucking crass thief is all he is. He's a fucking showman. He's so full of shit. All of this crap doesn't make any money. His companies are all bankrupt in function. And you're okay, that's the most intelligent human on earth. You're an idiot. All right, his work is way advanced. Oh, fuck you. His work, number one, he didn't do any of this shit anyway. He hires people. Don't you understand that? He doesn't know anything about rocket engines. He doesn't know shit about any of these subjects. That's why they're stupid ideas, is because he doesn't know shit about it. I'm not coming from creationism or religion at all. You're coming from deluded perception of your own competence. You are an idiot, all right? You're really not well informed, and you're full of opinion. You're an example of idiocracy. You're the problem, not the solution. Okay, I am science-oriented. What does that mean? It has pretty colors in it? You're science oriented, but you're not fact oriented. You're not detail oriented. That's what science is supposed to be about. I'm sorry, but this is just such gooey bullshit. All right, and go by logical reasoning. Says you. There's nothing logical about the way you measure intelligence on planet Earth if you think Elon Musk is an example of an intelligent person. He's a crook. Okay, Gary, we had these conversations before in 2000. Oh, great. So you're a dumbass who just is re-haunting me. Oh, well, then I have reason to block you. Okay, with Nick the Modern Mystic. I don't know if you remember those conversations. Well, I probably do. You're an idiot. Okay, my name is Nikki. Okay, well, you're an idiot. Yeah, again. A reoccurring idiot. All right. I had this big crush on you, but you were not into bigger chicks. So this is all important. You needed to type this on a public message board. You had a whatever problem, and I was supposed to in some way have the same problem, but whatever. But anyway, when I talked to you and Nick about cosmos being endless, neither one of you wanted to go there at all because it's retarded, because you have no information, psychic Wonder Woman. Okay, you have no facts. You just have your little personal delusion and you want to spread it around. Well, it's stupid. You simply ignored that yes, because there's no fucking evidence. You ignore things for which there's no evidence. You don't waste your time contemplating questions you can't fucking answer. You know, I could sit there and say, I wonder how much all the dirt in my backyard weighs. Why should I waste my time trying to figure it out when I know I'm not going to get the right answer? Oh, fuck you. And don't understand why. When you go by what scientists have speculated on so far and you end your search or theory up to a point of the Big Bang. Again, why would I even... I've said this so overtly. I couldn't give a rat's fucking ass whether it was a Big Bang, a big whimper, a big wobble, who the fuck cares but an asshole? Who the fuck thinks it has a goddamn fucking thing to do with the material universe, with charge, with gravity, with all of these subjects? It has nothing to do with it. It has nothing to do with understanding how we got here. Okay, 2 billion years of biological evolution. It has nothing to do with anything important at all. Okay, then you simply stop going any further. I go further, and it's not out of religion. It's out of your own delusional perception that you are something like smart, and you're fucking not. Unlike Nick and me, you're not very well educated. Oh, Jesus. I mean, phantasmagoria. Yeah, that's all it is. It's baby talk. Somebody smart doesn't waste their time answering questions that couldn't possibly matter. All right, it is simply going further. Going further into what? Speculate using reason and logic to say there was something before the Big Bang, or whatever, and the something was the big yellow chicken. Yes, Big Bird invented the universe. I mean, it's not a religion. Oh, okay. There was something before that as well, and it goes on indefinitely. Says you. You have absolutely no evidence, and how does it fucking matter if it did? Oh, that's right, it doesn't matter. I don't understand why that's taboo, because it's bullshit. It's a fucking idiotic subject that shouldn't be even entertained any more than somebody would entertain whatever, imagining women with 463 breasts. Why would I waste my time doing that? Okay, why do you end at... Oh, she keeps talking as if I'm ending. No, I'm saying there's no conversation worth having. It's irrelevant. It couldn't be more fucking irrelevant. There is always something that gives rise to something. Oh, she just keeps going. Okay, I'm done, really. So I'm just fucking done. I can't even read this crap. She just says the same shit over and over and over and over like it's important, when it's not. All right, so just fuck off. All right, so last one. I'm a real kind-hearted and gentle person with a big fucking mouth, typing a bunch of tripe, and you think you don't have to be accountable for it. You type tripe and you say, I get to do it for free. Nobody can ever insult me. No one can say, that's stupid as fuck. Yeah, they can. That's the real world. Welcome to it. I don't deserve to be psychologically abused. So you're claiming I'm abusing you by saying, get the fuck out of my face with this crap. You post this crap right in my face and say, I'm supposed to say what to it? It's something other than crap? No, it's fucking crap. Yeah, I love thinking about astrophysics. Yes, in a completely ignorant way. Yes, that's just so helpful. It's really great to have all the little retards saying I'm a very good driver when they can't fucking drive. Yeah, that's a great world to live in. No, it isn't. It sucks. Okay, you're a menace to reasoning, logic, science, facts. Okay, and philosophy, and I'm always happy to find people who are getting into these subjects. Getting into them how? By doing the opinion thing before they do the investigating thing. So you think you do science by first jumping to a conclusion and then trying to find something to back it up. And you didn't do even that. You can't even provide me the simple courtesy of explaining how the fuck you know any of this shit. Okay, but I'm very sensitive. I don't care. I mean, it's really not my problem. Everybody's very sensitive. I don't like people insulting me either. But tough shit. You showed up here, all right, and typed crap. You don't think you should get anything for it? Yeah, and it hurts my feelings when you deliberately insult me. Well, what am I supposed to do? Deliberately praise you? I'm not going to do that. So the only deliberate thing I should be doing is pointing out how you're an example of what goes wrong on planet Earth. Dumbasses who think they're smartasses. All right. So goodbye. Again. Ay. Oh, shit. Dave. Yeah, Dave. Your stock is going down. Yeah, lately. Gary Glitter. Yeah, thanks. I didn't name myself. Just point out. I didn't name myself. I had a twin sister. Gail Gary. Yeah, little cute thing. Has nothing to do with me. Fuck you. Really. Just fuck you. Alright, anyway. I mean, just look. Gary Glitter was some pedophile from England or something. Whatever. I've tried to stomach you several times over the last few years. Who cares? Why do I give a shit what Wes says? Wes. Oh, the important Wes is trying to do something. What's Wes doing? Let's see what Wes is doing. Oh, this channel has no content. That's what Wes is up to. So, yeah, I'm really interested in whether Wes gives a fuck. I really want to hear you. Who cares? It seems as if you might have something legitimate to share. Well, then that should be enough. Anytime I see a video that seems like it has something to share, I mean, even if the guy is, talking like a sissy or something and it's really creepy, he's like really, gayish, that kind of crap, and it's a little bit creepy. Yeah, I say, well, I'm going to listen because he seems pretty smart or he seems pretty something, so I'll get over it. He could be bald, he could have a big nose, could be drooling a little bit, have green teeth, lots of things, but I'll get over it. I won't feel like compelled to have to say anything besides, good stuff. So, I mean, the fact that you had this is a problem for you is your problem, asshole. Perhaps even amazing. So you'll go that far and then do this little whiny crap. Even if I banged styrofoam, I twisted styrofoam into styrofoam through the whole video. If I thought somebody was saying something perhaps even amazing, I would endure it. Just shut up and endure it. That's what I would do, personally. However, the quality offensive, so this sentence isn't even going to be in any kind of coherent arrangement of words, and this guy's complaining about irritating. Comments that aren't even written in like English, they're irritating as fuck. Yeah. However, quality, offensive vomit blasting out of your orifice makes viewers physically ill. I could say the same thing to you. So what's the difference? And you don't think some of this tripe people type isn't vomit worthy? Well, I'd say it is. It makes me ill to imagine the depth of your stupidity. Okay, and tells the plain truth. You are a literal poster child for the Dunning-Kruger effect. So you can't even see his hypocrisy here. You know, hypocrisy is one of the most disgusting things. So he's allowed to be offended, I'm not. So that's his first double standard. His second double standard is he'll say something as stupid as perhaps even amazing and then call it Dunning-Kruger. I mean, you can't have it both ways, asshole. It either looks like something good or it looks like something retarded. You can't sit there and pretend you can't tell the difference. That makes you an asshole. You can't tell the difference between retarded and valuable. That makes you pretty fucking stupid. You have no knowledge to share, well, except the explanations of the experiments. You only enjoy berating viewers for the purpose of... I don't even know what that is. Salvaging? Yeah, maybe. The twisted horror of your own ego. So, again, no evidence of this, that my ego has any twists in it. You're the people who look like you have some sort of ego problems. You're too sensitive, and you're too this, and you're too that. You're the little whiny bitches. Oh, amazing. I mean, so I'm not supposed to berate people who do things that I think are the cause of a disgrace and humiliation to the human race. I think that's the only reaction that's proper, frankly. You certainly shouldn't feed them. People just shut up. Please just shut up. Why? Did I step into your living room and do anything? No. Did I comment on any of your non-existent videos? No. You're the one who shows up here, asshole. This is completely voluntary. Your participation is not requested. I didn't invite you in any way. I didn't force you to show up here. I certainly know even YouTube doesn't force you to stay. I mean, what is this bitch? Oh, you just don't like what I'm saying. Oh, I get it. You want everybody who has an opposing opinion of yours to shut up. Well, yes, I'd like that to happen too, but I know it's not going to happen because I am smart and you're stupid. Okay, if you really have something to share, write a book. Why? Do people read books more than they watch videos nowadays? I mean, which one do you think is, let's see, if I had something to say, it seems like the president doesn't even write books anymore. They just Twitter, right? They just tweet back and forth to the world. At least I'm not just tweeting. I'm doing something a little thicker than that, a little denser, like this whole video, a whole list of chronicle of subjects. And frankly, why would I write a book about drafting something? I mean, you don't do the draft physics. You don't really do that in book form, right? You do it in a collection of notes. And that's what these videos have been, a compilation of note-taking, essentially, to make the argument. Now, when I'm ready to make the complete argument, then maybe I'll write the book. But again, who are you saying is going to read the book? And why would the book be any different than any other way of providing the content? What's the difference between me saying science has, quote, mined the evidence, and me writing it in a book? Why are those two things somehow necessarily, one of them is somehow the right way and the other way is the wrong way? Oh, that's right. You won't get any logical reason here. Yeah. And don't cite anyone else. Why would I cite someone else? What citation would I make to who? To you? Or it will just be written version of your toxic videos. Yeah, that's what it would be. And so again, you're saying this video was toxic, right? Explaining all the flaws in their reasoning and in their experiments and in how the experiments are conducted, that somehow that's toxic. When I'd say that's the only cure, is waking up and smelling the facts for a change. All you deluded little assholes living in your little fake world. So whoever the fuck you are, troll number 6,438, But that's all this is. This is trollish nonsense. You haven't counter-argued anything at all. You haven't made any kind of point demonstrating how I have made horrible, awful, egregious mistakes and how your beloved science has been pristine and beautiful in its function. Fuck you. Get what you deserve, okay, which is to be run over by an idiot. It is what they deserve, isn't it? I mean, frankly, a very good driver. I hope you get run over by a very good driver, because that's exactly what you fucking deserve. To be killed by the idiocracy you are a passionate member of. Alright, anyway, so that's enough. It's tempting fate for some... Okay, yeah, so I already read that. So, that's it. We're done, thankfully. Completed in more than an hour. Yeah, but anyway. So, the comment section. Just keep it relevant to the experiments. You know, this little comment bit doesn't count, so no comments on the comments, because I'll just delete them because they're a waste of time. Do it on some other video. Whine and complain somewhere else. So just comments regarding experiments and where they could be found on the internet and that kind of thing. Blah, 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 blah. And, of course, make sure they're not just trivial, stupid links. Yes, I've seen the double slit experiment. I've shown it. Okay. Show it done in one of the various ways I've indicated. Anyway. Till next time, such.